So you get the hang of how to figure out the number of covalent bonds that's needed, right? And with this in mind, we can now turn to the other part of covalent bonding which we need to handle, which is the dot cross diagrams. Yeah. Why don't we try an example for methane, which is actually made of carbon and hydrogen.
For methane, the first step is to figure out how many valence electrons each atom has. So carbon belongs to group 4. So it has 4 valence electrons. For hydrogen, it has 1 valence electron. So using the tip that you taught me above, hydrogen would need 1 valent bond to be stable, whereas carbon would need 4 more covalent bonds. Yes.
That's right. So since carbon needs 4 covalent bonds, so how do we plan? This is how we plan. Always plan your drawing before you actually draw it. Okay, yes. So we plan first and then we draw the perfect end product. Okay? So since each carbon requires 4 covalent bonds, this is how you show the number of covalent bonds it needs.
Yes.
Okay, and each hydrogen only needs 1. So can you see when we have 1 covalent bond by the hydrogen is already happy. It's stable.
Yes.
But we do need to do the same for the rest of the requirements by carbon. So we need 3 more hydrogens here. 1, 2, and 3. Like that. Can you see that?
Yes.
Okay, so the single line here actually, if we are to summarize the overall diagram, it would look somewhat like this, right? And the single line that I draw is actually a single covalent bond.
Yes.
Can you see that? So yes. This is what that final thing actually looks like.
Okay.
So let's now try to draw the dot cross diagram. Do you recall a very important feature you should always write for the dot cross diagram?
Yes, it's the key. So I can write the key. We can have cross to represent carbon valence electrons and dot to represent hydrogen electrons.
Very good. So what we do is now following the planned diagram as we can see here. Yes. Now we can safely draw. Okay, so what you do is you draw the valence shell for carbon, just like this, and then you surround it by 4 smaller ones because hydrogen only has a single electron shell, so it shouldn't be too big. We do observe relative sizes quite strictly when it comes to dot cross diagrams.
Okay.
All right, then you just label the center with the symbol. Okay, so after everything's said and done here, what you do is you now follow all these covalent bond planning, and then you just draw it here. So 1 covalent bond here, 1 covalent bond, this one as well here, and then the last one's here. Okay. So what you should notice, let's count the electrons to show you how it goes. Now for each hydrogen, do you notice that they have 2?
Yes.
Okay. 1, 2, then the next one, 1, 2, and 1, 2, and the last one, 1, 2 as well. Yes. So this actually shows that after having 1 covalent bond each, right? Each hydrogen is now already stable with 2 electrons on its single electron shell.
Yes.
All right. Now, when you look at carbon, right? Carbon, after following the schematic diagram that we've planned, carbon now has 8. Let's see, 1, 2, right? Then 3, 4, 5, 6, and 7, 8. Okay. So with this, you can see that carbon with its second electron shell is now also stably filled up with all the electrons that it needs.